7%. That's how many of your agent's model calls actually need a frontier model. Not 70, 7. Here's the run that number comes from. One agent benchmark 145 tasks, about 900 model calls. Send every one of them to Claude Opus 4.8 and the bill is $11.45. 9 cents a completed task. Now put something in front of the models that decides per call which one gets it. $3. That's it. Under 3 cents a task. Same tasks, same suite. 7% of those calls ever reached the frontier model. The other 93 went to a 30 billion parameter open model you can run yourself. That result is real, measured, published, 5 runs. I'll show you exactly what was measured, but there's a line item in that $3 bill almost nobody quotes. And it's why routing quietly fails for teams who copy the number. 2 of the 4 routing strategies in this thing charge you for the decision itself. That bill is in none of the write-ups. I'll earn it, it lands about halfway in. First, why this is suddenly worth building. Sending every call to one model was a reasonable default. When your good model was a bit better and a bit more expensive, routing was work you didn't need to do. Look at where those two numbers actually sit now. Same benchmark, same tasks. Capability, the frontier model scored 86%. The 30 billion open model scored 77.7, 8 points apart. Price, $11.45 a run, against 72 cents. That's about 16 times. 8 points of capability, 16 times the price. That's the whole argument, and it isn't close. The gap in what these models can do, stop tracking the gap in what they cost, and every call you send to the expensive one is a bet that this particular call needs those 8 points. So what made that $3 possible? A router. One decision per request instead of one decision per session. The one NVIDIA open source on the 11th of August is called NeMo Switchyard, Apache 2.0 on GitHub. The part that makes it usable in a real code base, it speaks OpenAI chat, Anthropic messages, and OpenAI responses natively and translates between them. Your agent keeps talking its own API and doesn't know it's being routed. You can point Claude Code or Codex straight at it and serve them from an open model. One honest note, NVIDIA's own README calls this pre-alpha. 4 strategies ship with it. Start with the one you are already picturing. The LLM classifier. A small judge model reads the incoming request, decides which tier it needs, and picks before the task runs. Watch the cars. Every one of them stops at it before it moves. NVIDIA's description adds a detail that matters. It keeps session affinity. Once it has chosen for a conversation, later turns stay with that model. This is what most people mean when they say routing. It's also one of the 2 that charge you for the decision. The judge is a second model call every turn in the benchmark we're about to look at. That's roughly 700 milliseconds sitting in front of your real call. Hold on to that. It comes back. Second, the stage router. This is the clever one. It makes no extra call at all. Look at where the judge was sitting a moment ago. That slot is empty. It reads signals already in the conversation, what your tools just did. Here's NVIDIA's own framing. Severe errors, repeated unproductive work, or prolonged exploration push the turn toward the capable model. Steady writes and edits favor the efficient one. Think about the actual shape of a coding agent's run. The front of it is exploration, reading files, guessing wrong, recovering, reading them again. That's the part that needs a good model. Then it finds the thing. And the back half is mechanical. Apply the edit, run the tests, fix the import, run them again. That's a different job. And it does not need 8 extra points of reasoning. The stage router is just noticing which half you're in. No judge, no extra call, effectively 0 added latency against 700 milliseconds for the one before it. RAMP used this one. Third, escalation. Start everything on the cheap model. A judge watches the task turn by turn, and when it sees sustained difficulty, it moves you up. One phrase in that sentence is doing a lot of work. Asterisk moves the session. Asterisk, not the turn, the session. Watch the strip after that switch throws. Nothing goes back. So a rough patch in the middle of a long task doesn't buy you one expensive call. It buys frontier pricing for everything that comes after it, until the conversation ends. That isn't a flaw. It's usually correct. A task that's going badly tends to keep going badly. But it does mean your bill is decided by your worst stretch, not your average one. Fourth, random. It splits traffic at a fixed ratio and never looks at the task. As a routing policy, that's useless. It'll send your hardest call to your weakest model for no reason at all. As a control arm, it's the most important one on the list. It's how you find out whether your clever router beat the task mix or just got a favorable draw. Now the measurement, because 74% cheaper is only worth something if you know what was measured. LangChain ran it properly, 145 multi-step agentic tasks, averaging 6.3 model calls each, drawn from 4 public agent benchmarks there on screen. 5 runs of the whole thing, so the variance is real. The configuration was the LLM classifier in escalation mode, routing between NVIDIA's Nemotron 3.5 Lightning 30 billion parameters, 3 billion active, and Claude Opus 4.8. The judge was Gemini 3.1 flashlight. Results: Opus alone 86% accuracy, $11.45 a run. Routed 80%, $3, 6 points of accuracy given up. 74% of the bill saved, 7% of calls went to Opus. That is the headline everybody is posting this week. It's accurate. And it's incomplete. Here's the line item. In that $3 run, split the spend 3 ways. Opus took 68.4% of it for 7% of the calls. That's fine. That's the trade. That's what you signed up for. Nemotron did 93% of the work. It took 10.4% of the bill. 68 and 10 is 79. So where is the other 21? The judge. 21.2% of everything you spent went to the model whose entire job was deciding which of the other two should answer. Read that back with the work in mind because it gets worse. The model doing 93% of the labor cost you 10% of the bill. The referee cost you 21. You paid the scorekeeper twice what you paid the player. And that judge was already the cheap option, flashlight. You can't fix this by shopping for a cheaper judge either, because the judge doesn't scale with difficulty. It runs on every single turn, whatever happens, forever. Which gives you the formula this whole video is really about. LangChain wrote it down, and it's 4 symbols. Minimum offload equals judge cost divided by the price gap. That's it. Your judge costs something on every turn. Each call you successfully push to the cheap model saves you the difference between the two models. Divide one by the other and you get the fraction of your traffic that has to go cheap before routing has paid for its own referee. Put their numbers in: 64 cents a run. Gap $10.73. 64 cents over 10.73 is 5.9%. They needed to offload about 6% of turns to break even. They offloaded 93% of calls and at 6.3 calls to a task that clears it either way you count comfortably. Now narrow the gap. 2 models $1 apart, same judge, and the formula asks you to send more than 100% of your turns to the cheap model, which is impossible. That isn't routing being suboptimal. That's routing being arithmetically unavailable. And there's a row on that results table I still haven't shown you. There's a row I've been keeping out of frame. That results table has 3 lines, not 2. Opus alone, routed, and the cheap model on its own, no router, no judge, nothing. 77.7%, 72 cents a run. Put all 3 next to each other and the shape of this changes. Opus 86, routing 80, Nemotron by itself 77.7. The whole capability gap is 8 points. Routing bought back 2.3 of them, about a quarter, and charged 4.2 times the cheap model's price to do it. Per completed task, it's the same story. 2.6 cents routed, 0.6 of 1 cent for the cheap model alone. And LangChain say this part themselves. The suite is saturated, everything scores high, so there is only 8 points of room, and routing has less to prove here than it would on harder work. None of that makes the 74% wrong. It makes it incomplete. Routing isn't free savings. It's 1 point on a line between 2 options you already had. Every number I've quoted you so far has been a single figure. It wasn't. They ran the whole suite 5 times, and the 5 runs don't agree. Across those 5 runs, the share of traffic reaching Opus ranged from 4.1% to 9.1%. Same suite, same config, same code. Cost per run, $2.16 at the low end, $3.61 at the high end. The bill moved by 67% between identical runs. Their conclusion is the useful one. Routing lowers your average spend and widens the range around it. Plan against the top of that range. If you've ever put a routing saving into a forecast, that's the sentence to take with you. The mean is not the number your finance team sees in a bad month. So who else has numbers? 3 tiers of them, and only the first is yours to use. Tier 1 is what we just did. A published benchmark, named sweets, a named configuration, 5 runs, variance printed next to the mean. You can go and rerun it. Tier 2 is vendor reported on internal benchmarks. RAM from earlier matched frontier performance while cutting cost 58% and runtime 33% on RAM's own SUI bench. Cognition ran the same idea inside Devin Desktop. Near frontier about 28% cheaper. Real numbers from real teams on benchmarks you can't see. And there's a third tier going round this week, a telco quoting 80 to 90%. No method, not even this system. I'm leaving it on the shelf. Not because it's false, because there's nothing you can do with it. Now back to the 4 strategies with the payoff in hand. 2 of them buy their decision with a model call, the classifier and escalation. That's the judge. 21% of spend and 700 milliseconds in front of every turn. One of them doesn't. The stage router reads tool activity that's already sitting in the conversation. Effectively 0 added latency and no judge line on the bill at all, which means the break-even formula barely binds on it. If your judge cost is near 0, your minimum offload share is near 0, and routing is worth trying almost regardless of the price gap. So if you take one build decision out of this video, try the stage router first. It has nothing to prove, no judge, no bill for the referee. Here's the test to run before you build any of this. 4 steps and 2 numbers you probably don't have. 1. Run your real workload on your cheap model alone. Not a benchmark your work. Write down accuracy and cost. 2. Run it on your frontier model alone. Same 2 numbers. 3. Divide your judges per turn cost by the difference between those 2 costs. That's your minimum offload share, the fraction of traffic you have to move cheap before the router pays for its own referee. And this is the number people get wrong. The judge bills per turn, not per task. Multiplied by your average turns per session before you divide, or your break-even will come out flattering and false. 4. Compare that to what your traffic can actually offload. If your minimum offload is higher than the share of your traffic, that's genuinely simple stop. You don't have a routing problem, you have a model selection problem. And if step 1 comes back good enough on its own, you're done. That's the cheapest routing decision available. Don't route. Back to where we started. 1 run, 900 calls, $11.45. Routing took it to 3, and it earned that. The price gap was 16 times. The judge needed about 6% of turns to break even, and the router cleared it several times over. But the same table says the cheap model on its own would have finished the suite for 72 cents and given up 2 more points. Both of those are true at the same time. And which one is right for you is not a benchmark result. It's an arithmetic problem with your numbers in it. So the question isn't whether routing works. It's this. What share of your calls actually need the big model? Most teams have never measured it. You can this week. If you want the layer underneath this one, why a long agent run gets worse before it ever runs out of room, that's the video on screen now. Subscribe if you want these broken down properly rather than posted as a headline.